Reporting live from Rhode Island University, I'm Wyatt. Today, the topic of discussion is wind turbines. And by that, we went to National Grid, which is an electricity company, to figure out how they take the electricity and convert it into energy.
My name's Tim Rowan. I'm the Director of Energy and Environmental Policy. Well, the good news is that we get to serve all the customers of Rhode Island for their electric needs except one small municipal light company. So they come to us because they need electricity. Now, we also work closely with our customers on energy efficiency programs. We also work with them if they are looking to install wind turbines or solar arrays or combined heat and power systems. If customers want to have their own generation on site, we work with them to make it as seamless as possible and to help but make sure that what they've done with their own generation won't affect the safety or reliability of the larger electric distribution system and just as importantly not affect any of the neighbors' power quality or voltage for their own needs when they use electricity. There is some sort of, relative when the blade comes by the tower itself, there's actually this subsonic noise that occurs every time it goes. It's a shadow, but it's not loud. You can't actually hear it. It's like your subwoofer, the really low frequencies that you can't hear but you can feel. That's typically the standard issue for neighboring customers and other people who live nearby. They can feel that. People a lot of times will assume that installing a wind turbine or any other solar array or whatever sort of generation, they'll assume that they can just essentially plug and play and they can just connect it to their wiring at their facility and it won't cause any problems for the neighbors. But the reality is the utility and our engineering staff have to study their proposed generation and how it's going to react in certain conditions during hurricanes, windstorms, during things like that, to make sure under any circumstances it won't cause any problems for the neighbors, and also that it's installed safely so that it won't affect any issues. If one of the key parameters we look at is what happens when the line where the customer's wind generator is connected to goes down for some reason. There's a car hits a pole, there's a squirrel that gets fried, that sort of thing. When that happens, we've got to make sure that that wind turbine or any generator on the system actually disconnects and stops generating electricity. Because what can happen if it doesn't, if that wind turbine continues to spin and continues to generate electricity, it'll feed power back out on a line that looks dead because you've got a car accident or something where the wires are on the ground. But in fact, it could still be energized, and that could be very dangerous and, matter of fact, deadly for our customers and their animals and everything else in the area. When the wind turbines are operating and they're generating more power than they need on site, the excess power is sent onto the electric distribution system, and they're paid for that excess power at approximately the same retail rate that most customers pay on their electric bills. So it's really more of it's hard to say who gets the electricity. Obviously the Portsmouth Abbey, it's right on their campus, and that is feeding their campus. But there's many times of the year where the turbine doesn't produce enough, where they have to take power from the electric distribution system to actually feed the school. Well, I think we can't ever marginalize the neighbors. The folks who haven't had to look at a wind turbine that's 400 feet high, and then someone suggests it, right? So we need to really work closely. URI, and the reason I mentioned URI earlier was that they've got this renewable energy siting partnership, that they're actually overlaying many different parameters as to siting of renewable energy. And for wind turbines, as an example, they look at the place where you have good wind. Yeah, it makes sense. They also look at places where zoning allows for it, and they overlay that to the wind. They also overlay how close the neighbors really are to it. So by overlaying all these different components and things, they'll be able to identify specifically where really the best locations for wind energy will be here in Rhode Island, and they won't run into the issues. I mean, the real shame is that over in Falmouth, they put up 4 wind turbines and they have to take one down now, which costs $2 million to put up and probably $500,000 to take down, just because it got situated too closely to a couple of neighborhoods.
Signing out, I'm Wyatt.